Hello! Yes! And welcome to part 2 of our Objective 17 notes. If you remember, Objective 17 is all about solving systems of linear inequalities. In part 1, we looked at a single inequality and graphing that. Today we're going to solve systems, which means we're going to have multiple. So it starts with some review because all we're going to do is we're going to graph two inequalities on the same coordinate plane. That's the only switch here, all right? So if the inequality is strictly greater than or less than, we use a dashed line. If it's less than or equal to greater than, it's solid. In graphing, we need to shade. All right, all of this is review. When determining, we can use a test point to figure out which side we need to shade. A good test point, of course, is 0, 0. It makes that algebra easier. Now, instead of just shading right away, remember, we're going to have multiple inequalities. So to determine which one we'll shade, we're going to use an arrow for both of them. And then where those arrows overlap, that'll be where we shade. That shaded region represents the solutions to the system. So with that being said, let's get started. Let's look at letter A. Y is greater than or equal to 4x minus 2. Y is greater than x minus 1. So let's start. We do this one at a time. Y is greater than or equal to 4x minus 2. Negative 2 is right here. Slope of 4. We go up 4, right 1, up 4, right 1, down 4, left 1. Solid or dashed line, greater than or equal to, so a solid. And now I need to determine which side of this line to shade. So I'm going to plug in 0. I got 0 is greater than or equal to 0 minus 2. Is 0 greater than or equal to negative 2? Yes, absolutely. So that means I will shade the side that contains 0, 0, which is this way. Now remember, since this is a system, we're going to use some lines here. All right, we're going to just use arrows to identify. I would shade that side of the line. Now for my second, y is greater than x plus 1. Plus 1 is right here. X tells me up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1. And I'm going to use a dash line on this one since it's strictly greater than. So a dash line there. Okay. Now when I plug in 0, 0, I get 0 is greater than 0 plus 1. Is 0 greater than 1? No, it is not, which means I will shade the side that doesn't contain 0, 0 of the dash line. So notice this dash line here. I'm going to shade the side that doesn't have 0, 0. I'm going to shade up and away here. So now the way systems work is I find we've split our graph ultimately into 4 quadrants, right? Or into 4 sections. We have 1, 2, 3, and 4. I need to find this section that both arrows point to. So the dash lines point to 1 and 4. The solid lines point to 3 and 4. Which one are they both pointing to? 4. So that'll be the section that I shade. All right. Let's try another here. X plus y is greater than or equal to 1. X minus 2y is less than negative 4. All right. Well, let's get this in standard form first. So x plus y greater than or equal to negative 1, subtract x, so I get y is greater than or equal to negative x minus 1. So that has a y-intercept of negative 1. My slope tells me down 1, right 1, down 1, right 1, down 1, right 1. Gorgeous. Now, am I going to use a solid or dash line here? Solid, right, since it's greater than or equal to. So a solid line. Beautiful. And when I plug in 0, 0, I can just use the original. It'd be 0 is greater than or equal to negative 1. Is that true? Yes, it is. 0 is greater than negative 1. So I would use my arrows to point toward 0, 0. All right. Now my other one here, x minus 2y is less than negative 4. So let's get it in standard form. So subtract x, I'll have negative 2y is less than negative x minus 4, divide by negative 2, divide by negative 2. And I find this to be y is, well, let's just make it equals 1/2 x plus 2. Very good. Y equals 1/2 x plus 2. So 1/2 x plus 2, my y-intercept is 2. My slope of 1/2 tells me up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2, down 1, left 2. Gorgeous. Solid or dash line here. Dashed, since it's strictly less than. Excellent. Gorgeous. All right, now when I plug in 0, 0 for this guy here, I get 0 is less than -4. Is that true or false? That is false. 0 is greater than -4. So this one will go away from 0, 0. And now I look for the set, or the section that all of the lines point to, okay? So I've really split it up again, all right? And you don't have to write these numbers. I think it's helpful. 2, 3, and 4. The dashed line points to 1 and 2. The solid line points to 2 and 3, which means this section here is going to be my shaded area. All right. Let's try a couple more together. Let's look at letter C. Y is less than or equal to -1/3 x plus 2. Y is greater than -2x minus 3. Well, -1/3 x plus 2. Y-intercept of 2, down 1, right 3, down 1, right 3, up 1, left 3, up 1, left 3. Solid or dash line here? Solid, of course. So I'm going to make a solid line. Gorgeous. Beautiful. Y is greater than -2x minus 3. Oh, I need to do my shading here. What am I thinking? So 0 is less than 0 plus 2. Is 0 less than or equal to 2? Yes, it is. So that means I'm going to shade towards 0, 0. There we go. Now y is greater than -2x minus 3. So -3. Slope of -2 will be down 2, right 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Plot a dash line here. Gorgeous. Okay. When I plug in 0, I get 0 is greater than 0 minus 3. Is 0 greater than -3? Yes, it is. All right, so this one, these arrows will point towards 0, 0. Looking for where these arrows point that overlap, it would be this section right here. And that would be my shaded area. Fantastic. Okay. Let's do one more together, and then we'll have you do some on your own. Looking at letter D. X minus 3y is greater than -6. 2x minus y is greater than 3. None of these are in slope-intercept form. Let's get them that way. So x minus 3y equals -6. Subtract the x. So -3y equals -x minus 6. Divide by -3. Divide by -3. Y equals 1/3 x plus 2. 2 is right here. 1/3 tells me up 1, right 3, or down 1, left 3. And need some dashes. Beautiful. Okay, 2x minus y is greater than, oh, shading. When I plug in 0, I get 0 is greater than -6. Is that true? Yes, it is. 0 is greater than -6, so I will shade towards 0, 0 here. Beautiful. 2x minus y is greater than 3, all right? So 2x minus y equals 3. Subtract the 2x. I do that, I get -y equals -2x plus 3, but I'm going to divide that by -1 so I can get y all by itself. And I get y equals 2x minus 3. All right, well, 2x minus 3, -3 is right there. Slope of 2, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1. Excellent. Solid or dash line? Dash line here. Beautiful. Gorgeous. All right, when I plug in 0, 0, I get 0 is greater than 3. That is, let's see, that's not true. That's false. 0 is less than 3. So this one will shade away from 0, 0, like so. All right, let's fill in this shading here. These arrows both point to this section. There we go. All right, let's have you try one on your own. Why don't you go ahead and try letter E. Go ahead and pause the video. Try letter E right now. Let's see how we do. All right, let's check in with you here. Looking at letter E, y is less than or equal to 1/2 x plus 2. 2's right there, slope of 1/2, up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2, down 1, left 2. Here we go. Solid or dashed line. Hopefully we drew a solid line since this is less than or equal to. When I plug in 0 for these, I get 0 is less than or equal to 0 plus 2. Is 0 less than or equal to 2? Yes, it is. So this one will shade toward 0, 0. Beautiful. Now y is greater than or equal to 3x minus 3. Minus 3 is right here. Slope of 3 tells me up 3, right 1, up 3, right 1, up 3, right 1, down 3, left 1. Solid or dash. Hopefully we drew dash since this one is greater than or equal to. Draw that line like so. And when I plug in 0, I get 0 is greater than or equal to 0 minus 3. Is 0 greater than or equal to negative 3? Yes, it is. So this one will also shade towards 0, 0. And when I look, again, I look for the section that overlaps, so hopefully we found that these sections overlap. Beautiful. All right. Raise your hand if you struggled with that one. Let me know. I'm happy to be around and answer questions. Otherwise, why don't you go ahead and try letter F. Go ahead and try letter F on your own. And let's see how we do here. Pause the video, try letter F. Ready, go. All right, let's check in, see how we did with letter F. Now, both of these are in standard form, so hopefully we started by getting them in slope-intercept form. So, start by subtracting the x, so negative 3y equals negative x plus 6, divide by negative 3, divide by negative 3, and we find that y equals 1/3 x minus 2, right? Positive divided by a negative gives me that negative. Minus 2 is right here, so up 1, right 3, up 1, right 3, down 1, left 3, down 1, left 3. Solid or dash for this one? Dash, since it's strictly less than. And then when I plug in 0, 0, I get 0 is less than 6, which is true. So this will shade toward 0, 0. Excellent. All right, 5x minus 3y is greater than negative 6. Let's try this one here. So 5x minus 3y, got to get it in slope-intercept form. Subtract the 5x, subtract the 5x. So I get negative 3y equals negative 5x minus 6, divided by negative 3, divided by negative 3. When I do that, I find y to equal 5/3 x plus 2. Interesting. Plus 2, 5/3, well, that'd take me actually off the graph this way. Let's go down 5, left 3. That'll put me here. All right, solid or dashed line, dashed, like so. And we can draw some arrows continuing it. All right, when I plug in 0, 0, I get 0 is greater than negative 6. Is that true? Yeah, it is. 0 is greater than negative 6. So that means I shade toward 0, 0. And now look, see where those arrows are overlapping? This section right here. All right. Hopefully we're feeling confident. I want to go ahead and look at letter G together. Let's look at letter G together here. X is greater than or equal to 3. Y is greater than negative 5/3 x plus 2. I just wanted to make sure we understand how we're graphing. X is greater than or equal to 3. Think of that as x equals 3. What type of line is that? That's a vertical line, right? X equals 3 is a vertical line at 3. Solid or dash? Solid, since we have that greater than or equal to. So a solid line here at 3. And then I'm saying if I plug in 0, 0 is greater than or equal to 3. Is that true or false? That's false. 0 is less than 3, so not true. So this will shade away from 0, 0. Now looking at my second inequality here, y is greater than negative 5/3 x plus 2. Well, plus 2 is right here. Negative 5/3 would tell me down 5, right 3, up 5, left 3. That would take me just barely off. Solid or dash line here? That would be dash, since it's strictly greater than. Gorgeous. When I plug in 0, 0 is greater than 0 plus 2. Is 0 greater than 2? No. No, it is not. That is not true. So I'll shade away from 0, 0. That'll take me this way. So I'm looking for the overlap of these lines. What I see is this overlap right here. Gorgeous. All right. Why don't you try letter H on your own? It's kind of similar. Go ahead and try letter H. Pause the video. Let's see how we do. All right, let's check in with you here. X plus y is greater than or equal to 2. Y is greater than 1. Well, y greater than 1 is similar to y equals 1. All right, that's a horizontal line at 1. Now, solid or dashed because it's strictly greater than. And if I plug in 0, I get 0 is greater than 1. Is that true or false? That's totally false. So this will shade above this dashed line. Now, x plus y is greater than or equal to 2 is not in slope-intercept form. So let's get it that way. All we need to do is subtract x. We'll get y equals negative x plus 2. So that says a y-intercept of 2, a slope of negative 1. So that means down 1, right 1. Solid or dashed line here. Hopefully we remember to draw a solid line since it's greater than or equal to. And when I plug in 0, I get 0 is greater than or equal to 2. Is 0 greater than or equal to 2? No, 0 is less than 2. So this will also shade away from 0, 0. And when I look for that shaded section, I'm looking for the overlap. That would be right here. Fantastic. All right, there's 2 left. I'd like you to go ahead and try them on your own. Oh boy, what's going on? There we go. All right, 2 left. I'd like you to try them on your own. Go ahead and do J and K on your own. Let's see how we do. Go ahead and pause the video, try J and K, and then we'll check it together. Okay, let's see how we did on these last 2 examples for Objective 17, J and K. Here we go. Looking at 3x minus 2y is less than or equal to 2. X plus 2y is less than or equal to 6. Neither of these are in slope-intercept form. How helpful. Let's put them that way. So I have 3x minus 2y equals 2. I'm going to subtract 3x. I get negative 2y equals negative 3x plus 2. Divide by negative 2, divide by negative 2. So I get y equals 3 halves x minus 1. Y-intercept of negative 1. Slope of 3 halves tells me up 3, right 2, up 3, right 2, down 3, left 2. Solid or dashed line there. Hopefully we remember to draw a solid line. Gorgeous. And when I plug in 0, 0, I get 0 is less than or equal to 2, which is totally true. There we go. Fantastic. All right, so we got the shading ready to go for that one. Let's try x plus 2y is less than or equal to 6. All right, so I need to subtract x. When I do that, I get 2y equals negative x plus 6. I can divide by 2, and that tells me that y equals negative 1/2 x plus 3. Plus 3 is right here. Down 1, right 2, down 1, right 2, down 1, right 2, up 1, left 2, up 1, left 2, up 1, left 2. Fantastic. Y equals negative 1/2 x plus 3. Solid or dashed line? Solid because it's less than or equal to in that original inequality. Solid line there. When I plug in 0, I get 0 is less than or equal to 6. Is that true or false? That's true. 0 is less than or equal to 6. So that means I'm shading towards 0, 0. With that being said, I see that this section here is my shaded area. All right, hopefully we're feeling confident with J. Let's go ahead and look in at letter K. Y is less than negative x minus 2. Y is less than or equal to 2/3 x plus 3. Both of these are in slope-intercept form. Nice. So we have a y-intercept of negative 2 from that first, and then a slope of negative 1. That tells me to go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. Solid or dashed line here. Hopefully we remembered it to be dashed. So dash this up here. Very good. All right. Shading wise, when I plug in 0, I get 0 is less than 0 minus 2. Is 0 less than negative 2? Oh, no, it's not. 0 is greater than -2, right? So I will shade this away from 0, 0. That's going to be shaded this way. Okay. Y is less than or equal to 2/3 x plus 3. 3 is right here. The slope of 2/3 tells me up to right 3 or down to left 3. Down to left 3. Solid or dashed here? Solid, all right, since it's less than or equal to. Solid line. And when I plug in 0, I get 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3? Yes, it is. So this one will be shaded toward 0, 0. So it's going to be going this direction, which shows me that the overlap is right here. Fantastic. And that concludes our Objective 17 notes. Raise your hands if you have any questions. Happy to help out. Otherwise, why don't you go ahead and get started on the check for understanding that's up on the board. Mr. Carter signing off. I will see you next time.